All right, gang. So home stretch here. I know that third section, there's a lot. And again, if y'all have any questions and you want to contact us offline, myself or Mimi would be glad to talk to you. She's obviously the guru at this, so I'll defer to her excellence. But again, this being a requirement moving forward, it isn't something we're just going to dump on you, and we hope that what we've learned here today we can use and make sure we make it a smooth transition implementing this new part of our data collection. So whether you're science or a contractor. But again, here's Mimi, and we'll wrap after this.
So this last section, introduction to software documentation. So the basic philosophy behind software documentation is that the way science is being done now with so much technology and technological advancements, you can't really get full science reproducibility by just sharing your data sets or before that, just writing papers. Science is built on being able to reproduce itself, to be reproducible, which is that, someone can take your paper or your report, read what you wrote, and, and there's enough information in there, enough details that they can actually do exactly what you did and come up with the same results. Because of so much technological advancements and computing power and stuff like that, and also the sheer volume of data that is now possible to collect. And, data sets have become very large and complicated. And then the software to process the data has also become very complicated. And so in order to fully explain what you did in a way that someone else can actually reproduce what you did, they need not just your paper and not just your data set, but also the software to process the data set and enough information about the data set that they can, take the raw data that you put out, take the software that you wrote for it, use the software on your data, and process it in the same way that you did it, and then come up with basically the same final data set that you did. So that's kind of the whole goal of software documentation. Okay, so what is software? When most people see the word software, you're probably thinking of things like something you can buy in a box that for large sums of money, like Microsoft Excel or Microsoft Word or whatever is software. But when we're talking about software here, we're not talking about anything quite that fancy. It's basically any type of processing script that you've written to automate your data processing is included in the definition of software. And that includes not just the processing software, it also includes visualization software, data analysis. So if you write things in MATLAB code or R code or Python or Perl scripts to reformat your data in such a way that it's going to be importable to something else, all of that counts as software. All of that needs to be made available so that other people can use it and be able to use it on your data to reproduce what you did. So, a lot of the stuff that you might have written that's extremely customized for your data set, and in a lot of cases, it can be generalized to process other similar data, and someone else who's not as good at computer programming might, they might be searching the web looking for some way to process their data in an automated way, and if your script is available, they can just take that and use it instead of having to come up with writing it on their own. Okay, so here's a graphic that shows why it's important to have data prep software made more available. There are a lot of scientists and engineers out there all doing different things, and a lot of what they do is they take, they're either collecting their own data or they're downloading data from somewhere else, and they have a model or like MATLAB or whatever that they want to import it into, and it's not formatted in the way that they need it to be. For example, it could be a NetCDF format, it could be a PDF, it could be text files, it could be an Excel spreadsheet, but the column headings are not arranged in a way that works for them, and so you spend a lot of time rearranging columns, rearranging your data, converting units and all of that fun stuff. And you're spending more time doing all of that than actually doing science with the data. Here's a graphic, kind of this is from PhDcomics.com that sort of gives you a typical scenario of the problem. You have a new incoming student or postdoc who's adding on to a project that has been going, and a previous person did stuff, and now you want the new person to do stuff, but they didn't bother to write comments for the code or any instructions for how to use it, and so this new person pretty much is going to be spending a huge amount of time trying to figure it out, or they're going to just dump the whole thing and start over from scratch. And that takes up a lot of time and effort that could be spent doing something productive that's actually science and not, preparing to do science. So that's why it's important to, one, make software available so that other people can use it, and it'll save their time. It'll save your time in the future also if your stuff is organized. And so just sort of a brief list of things to keep in mind. Organizing software to make it ready for publication is very similar in some ways to making data ready for publication. You want to organize it in such a way that it's going to be understandable to other people. If you have a lot of code, you want to comment it so that you want to know what each individual for loop is doing and why it's doing it. You want to make sure it's going to run on, well, first of all, it has to run on whatever you're personally using, but making it run somewhere else is helpful. Making it modular means that you have like specific pieces of it that does specific things. When you're doing an entire series of data processing steps, you might have it all like a MATLAB file, for example, could be several thousand lines long and do a whole bunch of different things. But if you can break it up into smaller components so that someone else who wants code to do just that specific component can just take that part of it and use just that part of it. You want it to be configurable. If you're going full out and putting it up on, like, for example, GitHub or something, and allowing other people to help develop it, you want to have test data so that they can see how it works. They'll feed test data into the code to see what comes out at the other end, so to see if it's going to be usable for what they're trying to do. So all of those sorts of organizational type of things, it does take a lot of work to do that, but it pays off in the long run because you're saving yourself you're putting in a lot of work up front, and then later on, like 10 years later when you're working on a different project and you need to do the same kind of data processing on something else, you can just use the same code, and 10 years later you're not going to remember the details of what you did the first time. So if you do all of this up front at the beginning, then later on it'll save you a lot of time too, not just other people. So okay, so there's NSF has an EarthCube program that funds a number of different projects, and one of the projects it funded was called OntoSoft. And what OntoSoft did was develop a metadata standard for software of the type that we were just talking about, processing scripts and things like that. The link here, I'm actually not going to click on this one, but it'll take you to their website and it'll give you the full documentation of their metadata standard. Everything that went into how they designed it, and it's an extremely long and detailed technical document. So we're more interested in how to actually use it for the stuff that we're doing. So just like the data sets have different categories of types of information you want to go into it, software does also, and it's broken up, in this particular standard, it's broken up into 6 sections. Here's a slightly more detailed look at what kind of information is in the sections. So identify would be the basic stuff like, what is the name of the software, what does it do, where is it located, and understand, trust, quality and ratings, the software quality, how well does it have lots of bugs in it. Execute is about how do you use it, where can you find it, you access it, download it, how do you install it, how do you run it, This would be, if you have references to your test data, that's where you would talk about that. And how well does it work to, if you're using it in a part of a larger workflow of lots of processing scripts, where does it fit into the bigger picture? More widely used software tends to have like forums where you can ask questions. If you run into bugs, you can discuss it with other people who are using the same thing. If the code is on GitHub, for example, and you have multiple developers of it, you'll have discussion and then contribute, well, actually update it. And then, you have different versions. So, for example, my personal example is to do stuff in MATLAB, and MATLAB upgrades itself every few years. So you have like 2011 version of MATLAB will have scripts, and then they move it to 2015. And then all the scripts that you wrote for the 2011 version doesn't work anymore, so you have to write slightly different versions, and you'll want to be able to track all that. So, okay, so now we're going to go to the AutoSoft portal at DISL. Okay, so we saw those 6 pie chart sections. This is the portal that will allow you to write software metadata in a very nice fancy GUI, so you don't have to keep track of the actual backup, because it's actually, the final document for this is also in XML. There's XML, HTML, and something called JSON that you can when you make your final document. But they have come up with a pretty good graphical user interface so that you can enter all of that information in a series of forms and not have to worry about any of that. And they are better programmers than me, so it actually looks better than my thing. But okay, so I've already created, before I get that far. So DISL has a portal for doing all of this. They have several portals that they're running, and we have one. It's free. You can just go in there, create your own login. If you click register, it'll allow you to create a username and password and send it to you in email and all of that. I already have one, so I'm just going to log myself in. Okay, well, that's me, but yeah. Anyway, so then you go back to the software repositories under software. I think home is just the intro blurb software. And over here you can search the kind of software that you're looking for. And the DISL one doesn't have a huge number of them so far. There's 3 of them that I wrote. So you can search on author and just get pretty much me, because here I am. These are all mine. When you want to write okay, if it's your software, you just click through one of these, right? Okay, first you can just read it over. And you can download it into these formats. Identify, here's the pie chart. And here's all the information I fill out for identify. Here's understand. Execute. You just scroll down and all that information is going to be in there. Okay. If it's yours, then you can actually edit. So the way the pie chart works is that if it's completely green, it means that you filled out all the mandatory fields that we have. So here's identify what's it called, here's the name of it, here's the description of what it does. And in each case you have the importance means mandatory. And in optional, you can also fill out additional information. This one doesn't have a DOI. It's part of a larger package that has a DOI, but the specific one doesn't, so that's blank. Just kind of go through and find out. It'll just ask you really simple questions that are easy to understand. And you fill out the information, important or optional. Just edit all this, and when you're all done, there's a save button somewhere right here. Well, I guess it's already saved, so it's not going to let me do it. But all right, so that's how you. So it has a pretty good editor. It also has comparison tools, so that if you're looking for software, you can do a search on the type of software you're looking for, and it'll give you a montage of 3 of them. And you can compare. If you are making a blank, you can say publish your software, and then you just come up with the name of your software. I guess for MATLAB is M. And you can see that the pie chart is red because it's completely blank. So as you go through, name, save. As you fill things out, green means that you made some progress. So you'll see when it's completely red, it means you didn't fill out anything. When it's completely green, it means you filled out all the mandatory fields. And when you partially fill it out, it will fill up the pie chart to tell you how much of it you still need to do and how much of it you've done. You can save each time. So. Anyway, so that's how that works. And in order to get to it, here's the link. This is a direct link right here. You can also go on the DISL website. There's a link to it up here. Also, under the last little section, metadata for science software, there's the portal links over here. And this will give you a little bit more information about what the standard is all about. So I think that's all of it. Yeah. Okay, so that's the software. So each individual processing script you can document on the AutoSoft portal. And the people who are running AutoSoft, the project, they are actually extremely interested in getting feedback on how the AutoSoft portal works and whether if it's working well. Then bug reports or whatever, just general feedback on whether you like it or not. So as you're going along trying to document stuff, you can send them an email and tell them what you think. Basically, I guess it's not a beta exactly, but I'd say late alpha, early beta stage at this point. They are hoping to eventually make it more broadly accessible and publicly available. So as much feedback as you can give them would be good. Okay, so once you have a bunch of software, you have your data sets, and you have the software, the processing scripts. And when you have a sequence of processing scripts, what you have is a workflow. So you start with your raw data. It goes through some processing scripts. It goes through some intermediate stages. It goes through more processing scripts, and then you eventually get to your final data. And the workflow of what happens to all of this data can be extremely complicated, and it can be useful to diagram it all out. You can either just diagram it in PowerPoint as a sketch to be really quick and sort of a back of the napkin approach. There are also pieces of there's actual workflow software that you can use to be more official about it. So here's an example workflow. This is a moored set of instruments offshore of Dauphin Island. It's a vertical array of instruments that take temperature data. I think it's like 1-minute data for the most part. There's an ADCP at the bottom that measures current velocity, and keep talking. Okay. Anyway, so this shows, here's the instruments, here's the raw data that comes off of it. It goes through these pieces of software, proprietary, and then after each individual one, because each manufacturer has a different proprietary software that talks to their instruments, so each one goes through a slightly different path. And then, once you have the minimally processed stuff, you wanted to be able to integrate it all back together. I was trying to use MATLAB to do it, so. But MATLAB is very specific about what formats it can import, and so first I ran it through a Perl script to make sure that all of it was going to be importable to MATLAB. And then once it's in MATLAB, there's some manual steps to figure out, which parts of the data is actually usable and which parts are just junk data, like from before and after the deployment of the instrument. and put out a bunch of files at the end. And there's a similar path for the ADCP with the current velocity data. And once I've made this diagram, I also wrote a paper that explains this workflow in great detail. The whole point of this exercise is just that someone else can take the same raw data and know what you did to it, you know, every single individual step, all of the parameters that you set, and come up with the same final figures and files at the end. That when you publish the final figures in your paper, they know where it came from and how it got there. Okay, and we are done. All right.